Hello everyone, this is Krishna Rana and welcome to my channel. Today in this video we will be going to learn about how to protect your sensitive data using different types of encryption technique provided by SQL Server. Well, for any organization, data is the most critical business asset. SQL Server provides several ways to encrypt the data using symmetric keys or asymmetric keys and certificates. So in this video, we will learn two different encryption techniques. In the first demo, we will see how to implement the column level encryption using symmetric keys. And then in the next demo, we will see another technique which is transparent data encryption, and it is also known as TDE. We will implement this TDE technique step by step. Okay, in today's time, for any organization, it has always been in priority to secure data from unauthorized access or unwanted use from the data thief. As I said, SQL Server provides several ways to encrypt your data from column level encryption to drive level encryption. So column level encryption can be achieved using the symmetric key or asymmetric key in combination of certificate or password. We will create this symmetric key and we will see this in action in the demo part within a few minutes. But here, first of all, let us understand what do you mean by symmetric key and asymmetric key. Okay, what is symmetric key? It is a technique in which only one key, or you can say a same key, is used for performing both the encryption and decryption of the data. It encrypted the plain text and converted to the cipher text using the key and some algorithm. And to decrypt that cipher text to the plain text, it uses the same key. Now, what is asymmetric key? Okay, asymmetric key, it uses a pair of key, it uses a private key and public key to perform the encryption and decryption, while symmetric key uses the same key. So in asymmetric key, it uses the public key for encryption of the data and private key for decryption of the data. In the demo part, we will see how to create symmetric key and how it helps us to perform the column level encryption. Now let's come to this file level encryption. The file level encryption can be achieved using the TDE technique. We will implement this TDE demo within a few minutes. We will implement this TDE technique step by step, and then now let's come to the another level, which is folder level encryption. It means you can encrypt the whole folder using this NTFS encryption technique. And then there is a drive level encryption, which encrypts the drive using this BitLocker encryption. Okay, the last two levels are out of scope for this video. SQL Server uses encryption keys to encrypt the data, but that encryption key itself be stored as encrypted using another keys or password. As shown in this encryption hierarchy, each layer encrypts the layer beneath it by using a combination of certificates and symmetric keys. So in the encryption hierarchy, top layer is the Windows OS layer, which uses a Windows Data Protection API for encryption. And then we have a SQL Server layer, which uses a Service Master Key for encryption. Well, Service Master Key, or you can say SMK, is created by SQL Server setup. So there is only one Service Master Key per SQL Server instance. And then we have a database layer, which uses a database master key for encryption. Now this database master key is itself encrypted using its above layer using its service master key. So in short, in encryption hierarchy, each layer uses its above layer to encrypt itself. Okay, as I said, in this video, we will implement the two techniques. In the demo 1, we will implement the column level encryption using symmetric key, and in the demo 2, we will implement the TDE step by step. So let's jump into the demo. Alright, so for demo purpose, I have already created one database. This and it already contains this sample table, and this table contains some sensitive data, which is order amount, payment method, credit or debit card number, and bank name. Now I want to encrypt this column and this bank name column. So how we can achieve it using this column level encryption? So first let us create this symmetric key. To create the symmetric key, we need to perform this command. Here you need to specify the key name, and then you need to specify the algorithm. You can use different types of algorithm, but AES-128, AES-192 depends on your requirement. But Microsoft will suggest this three algorithm. So we will use this 128 algorithm. Here you need to specify some strong password. In my case, let's create this symmetric key. So okay, now we have successfully created this symmetric key under this database. But where you find this key? So you can find it. Go to the security folder and over here. Now let's perform the encryption of some simple plain text. SQL Server provides two functions to encrypt this to encryption and decryption. First one is encrypt by key, and another one is decrypt by key. Let's see how we can use this encrypt by key function using the symmetric key. So as you can see that in the argument, here we need to specify the symmetric key name in combination of this key GUID function. So let us use and let's specify some text. Now let's run this command. Okay, so why you get this null value instead of some encrypted value? Okay, so to perform the encryption, you need to open this symmetric key. So for that, we need to perform this command. Open symmetric key, name of the key, decryption by password equal to, and then it is better if you close this key. Now if you perform this action, yes, now you will get this the encryption of this plain text in var binary format. Now let us decrypt this var binary value. Let me declare the variable. And now let us decrypt it. Well, this decrypt by function returns some var binary data, and we need to convert it into the varchar value using let's run this function. So yes, encrypt key function convert this simple plain text to the var binary value, and then decrypt by key function will return this cipher text value to this plain text value. Okay, now as I said, I want to encrypt this two column into this where binary. So let us add the new column from that action. Let's run this command. Now let's check this again. So we have added this two new column. Now let's encrypt this two column value and assign the where binary value into this two new column. You need to perform update function, update payment master set number using by key TGY. Okay, now let's perform this update statement. Let me copy this below this. Now let's check the data. So yes, we get the encrypted value of this two column. Now let us drop this two column. Let's re-verify again. Okay, so we have removed that two column. Now let us decrypt this two column value. Let me copy this command. Value, select. First of all, let's convert into the varchar. Then we will use this decrypt by key function, where you need to where we will specify the column name. Now let's run this query. So as you can see that we will now get the decrypted value using this decrypt by key function. Well, you can also assign the roles, and you can also assign the rights to the user to see this encrypted value. Revoke. So let me revoke the permission from the user. So for that you need to perform the below query. Revoke view definition on symmetric key. Here you need to specify the symmetric key name. And then you need to specify the username. Now I don't want that this user can see my decrypted data. So using this command, I'm going to remove the rights from this user. Okay, now let's do the login of this user. Let me open the new query. Now let's run the same command under this user. Let me execute. So as you can see this this query right now fire the exception which told me that cannot find the symmetric key because it does not exist or you do not have a permission. So now let me assign the rights to see the decrypted value. For that I need to use the grant function. Let me execute the same. Now let's run the same query again. So yes, now you can see the decrypted value of this for under this user. So that's it from the demo 1. Now let's jump into the demo 2. Okay, before we go ahead and implement the TDE technique, first let us understand about it in some brief. Transparent data encryption was initially introduced in SQL Server 2008, but in Enterprise Edition. TDE provides file level encryption. It means it won't encrypt your actual data resided in your table, but it encrypts the physical files of the database, such as .mdf file, .ldf file, which is transaction log file, and .bak files, which is backup files. Its main purpose is to prevent unauthorized access to the data by restoring the files to the another server. So it's like assume that if someone have stolen your database BAK file and try to misuse it by restoring it in their instance. So let's see the TDE in action to prevent that type of activity. So here first we will create a master key, which you can say is a symmetric key, and it is used to protect the private key of the certificate present in the database. We will create this master key under the master database. So in the step 1, we will create a master key, and then in the step 2, we will create a self-signed certificate. Now these two steps are very important because without this original certificate and the master key, one cannot read or restore your database. Okay, so here in SQL Server Management Studio, will be going to create a master key under the master database using the following query. Let's create the master key. Here you need to specify the password. Let's create this key. Okay, now let's in the step 2, let's create the certificate. Create certificate. Here you need to specify the certificate name. And here you need to specify the subject. Here you can optionally specify the expiry date, but let's say if you have not specified this expiry date option, then by default this certificate will expire in 1 year. It's okay if it is expired, because if it expire then it doesn't affect the encryption and decryption technique under the any database. So let us go ahead and create this certificate. Okay, so we have successfully created step 1 and step 2. Now let's move on to the step 3, which is creating a database encryption key. Now this database encryption key protects the data in the user defined database. We'll be going to create this key under the database on which we want to enable TDE, and then in step 4 we will turn on the TDE by enabling the encryption option of the database. Now let's see this step 3 and step 4 in action. Okay, so here I want to enable the TDE under this database. So I am going to create the database encryption key under this database. Now let us go ahead and write the query to create the database encryption key. We will use this database create. Here we need to specify the algorithm. We will use this algorithm using encryption by server certificate. which we have already created in these steps. So here we need to specify the name of the certificate. All right, now let's create this encryption key. So here, as you can see that when you create this DEK, it will give you some warning. It says the certificate used for encrypting the database encryption key has not been backed up. You should immediately back up the certificate and private key associated with the certificate. So yes, we will take the backup of the certificate and associated private key in the very few minutes. But before that, let us enable the encryption on this database. So for that, we need to write this command: alter database name, set encryption on. You can also enable this option by going to this database properties, go to the option, and over here you can enable and disable this encryption. So we have already enabled this option. So now this database is now TD enabled. So first of all, let us take the backup of this database. So we will going to create the database. BAK. Let's execute this command. All right, now let us take the backup of this certificate and master key. So first of all, we will take the backup of this master key using this command: file. Here we need to specify the name of the that key. Now let's run this command. Okay, now let us take backup of the certificate. Here we need to specify the private key. Encryption by password equal to let's run this option. Okay, so we have successfully created the backup of the master key, and then we take the backup of this certificate, and you can find all this information on this drive. So here we have a certificate, and here we have a private key file, and here we have our database.bak file. So now to pretend this instance as another server instance, let me delete everything from this instance using the following query. So first of all, let me drop the database which I have created, and then let me drop the certificate, and then let me drop the master key. Let us run this command. Okay, so as we have already dropped the database and its related certificate and master key, now let's try to restore that BAK file into this instance. But before that, let us refresh this node. So yes, our database is not present here. Now let's try to restore that database. So as you know that the database is now TD enabled database. So yes, now we got the following error. It says cannot find the certificate with thumbprint. So as you see that the TD enabled database cannot be restored without its original certificate and master key. So now let's try to restore the certificate and master key using the following command. First of all, let us create the master key. Specify the password. Let's run this command. Now let us restore the certificate. To restore the certificate from the existing, we need to create the certificate over here. So let's create the certificate. Now we need to create the certificate from the existing one. So here we need to specify from file. Then here we will specify we need to specify the path where we store the existing the previous certificate with private key. Decryption by password. Now let's run this command. So yes, the certificate is created now. Now let's try to restore our TD enabled database again. So yes, it's now successfully restored. Yes, we can find our table. So that's it from the demo 2. If you have any query or concern, you can ask through the comment section. If you like this video, then don't forget to subscribe my channel. Till then, stay curious, stay healthy, and thank you for watching this video.